Hey everyone, how are you? Today we are going to solve the second topic of our NeetCode 150 problem series, and the second topic is two pointers. We have already solved the arrays and hashing problems. It has 9 problems. We have already solved it, and you can find the video of that solutions on the I link. Let us today solve the 5 problems of two pointers. After solving these 5 problems, you will have a great understanding of two pointers technique, where those can be applied and how we can apply and use it. So let us go on to the easy problem first, which is a valid palindrome. In this first problem, we are given a string s and we need to return true if the given string is a palindrome, otherwise we need to return false. Now this palindrome is nothing but a string that reads the same forward and backward. It is also case insensitive and we need to ignore all the alphanumeric characters. Alright, see, the thing is, alphanumeric characters consist of letters from A to Z, uppercase, A to Z, lowercase, and numbers. And in the problem, we have to ignore all the non-alphanumeric characters, right? Now the thing is, again telling you, a palindrome is nothing but a string that will read the same going forward or backward. For example, I can say N-A-Y-A-N. This Nayan is a palindrome because if we read this backward, this will be N-A-Y-A-N. Both are same, right? See, the thing is, the question says that it is case insensitive. So this N uppercase and N lowercase, they both will be considered same. The first observation which you need to make here is, how is this a two pointer problem? This is a two pointer problem because we have to point at two different locations at the same time to compare those locations. For example, let me first write the indexes here. The indexes of our string will be 0, 1, 2, 3, 4, right? What we need to do is we need to compare the index number 4 with index number 0, right? Basically, the last index with the first index. This last n and the first n we have to compare. Are they same? Yes, they are same. Alright, let's now go inside the string and compare the next two strings or next two characters. So the index number 3 and index number 1, this particular a and this particular a you have to compare. And now we are at index number 2, and both our pointers, the left pointer and the right pointers, are pointing at the same character, which is y, that is the index number 2. So this is why it is a two pointer technique. Now before we start solving the problem, we have to understand few things, that the comparison should be case insensitive and we have to ignore all the non alphanumeric characters, right? Alright, so let's start solving it. What we can do is we can say there is a left index which will be the index number 0, the first character of our string, and there will be a right index that is going to be the length of s minus 1, that is going to be pointing to the last character of our string. Now we can run a loop while the left is less than right. Alright, why are we doing like this? I will tell you. Let us say we have a string y a t h, not h, let us say b a y. Now the indexes are 0, 1, 2, 3, 4, 5, right? If this would have been a palindrome, then we would have first reversed this, right? If you reverse this, it is going to be same. First it will be y, then it will be a, then b a y, right? Basically this is the y. Now it is here, this particular a is here, this particular b is here, not here, it is the second index. Then we have this particular b, then we have this particular a, and then we have this particular y, right? So basically the indexes are also reversed, 5, 4, 3, 2, 1. Now if you compare these two strings, you are actually comparing the index number 0 to index number 5, index number 1 to index number 4, index number 2 to index number 3, and then index number 3 to index number 2. Basically we are now trying to do the same thing. So what we can do is we can say our left index is 0, our right index is 5, and we are going to compare 0 and 5. If they are same, then we are going to compare 1 and 4, then we are going to compare 2 and 3. Alright, so let us do it. We can say we have a left index, then we have a right index, and now we have to say if s of left is equal to s of right, then we are good, right? In this case we can say left plus equal to 1 and right minus equal to 1. Else we can say return false anytime they are not matching. For example, let us say there is a string a b h j i a or b. If we compare the first character and the last character, they are not same, right? If you reverse this, this will be b i j h b a. So they are not same after reversing, right? They do not read same forward and backward. So anytime if the two characters we are comparing are not same, we need to return false. If we are out of the loop, we can return true because we did all the comparisons, and after comparing everything is fine. All the characters are same. It means they read the same going forward and backward. They are palindrome. Now if I run this is not going to pass all the test cases. First of all, let me actually delete this. This is not a valid Python code. Now if I run this, this is not going to pass all the test cases. Alright, so we have an indentation issue. Let's actually get rid of this indentation issue. This should be, I think this should be one space forward, then this right should be forward, then this should be forward. Oh, alright, so I think the indentations are fine now. Alright, so you can see test case number 2 is fine, test case number 1 is not fine, it is not working. The reason is, if you see here, you can see that this string contains characters like question mark, which is not a alphanumeric character, and the question says that we have to ignore all the non-alphanumeric characters, right? So what we can do is we can actually first of all filter out all the characters from the string which are not alphanumeric. First of all, let's get rid of this all the non-alphanumeric characters from the string. So we can say s is equal to, let's convert this string s. We can say first of all, let's create a list. It will be for c in s, and what we can do is we can say if c dot is, I think there is a function in Python which is called is alnum. This checks that is this character alphanumeric or not. If this character is alphanumeric, we are going to include this in our string or in our list. Otherwise, we are going to exclude this. Basically, this logic is going to filter out all the characters which are not alphanumeric. So now our string doesn't contain any alphanumeric characters, but now our string length is changed, right? So we should better assign the left and right index after we have filtered out all the different alphanumeric characters, right? Non-alphanumeric characters, right? So I think now this should be fine. If you run this now, still it contains one issue, I will tell you. Still the test case number 1 is not fine, and I will tell you the reason. If I print the value of s, let us say we print the value of s and run this, you will see that the string s doesn't contain any alphanumeric characters, but the thing is this w is uppercase, this w is lowercase. Both will not be equal, but we have to do a comparison which is case insensitive, right? So what we can do is we can say c dot lower. Let's actually convert all the characters into a particular casing, either uppercase or lowercase, both are going to work. If I run this now, this should be fine. Yeah, you can see it is accepted. It means all the sample test cases are fine. Let me submit this and let us see is this accepted or not. Are all the test cases accepted? Yes, all the test cases are accepted, and we have solved this particular problem. Let's go through the solution quickly to understand it. First of all, we have filtered out all the characters which are non-alphanumeric from our string, and we have converted every character to lowercase so that the character comparison is case insensitive. Now we have assigned 2 pointers, left and right, and it is like saying that I am going to go from left and right comparison. So first of all, the comparison will be between w and w, then the comparison will be between a and a, right? So this is how we are doing the comparison, because inside the loop we are having a loop, while loop, right, from left to right, and if both the characters are matching, we are going to say left plus equal to 1, right minus equal to 1. So your pointers in the left side will be going in the right side, your pointer in the right side will go in the left side. And anytime if the characters are not matching, we can directly return false. But if we are out of the loop, we can say that all the characters are matching at their specific positions, so we can return true. So this is the complete solution for this particular problem, and I think we have solved the first one. Let's go on to the second one, which is 2 integers sum part 2. This is a medium level of problem. In this problem, we are given an integer array numbers. Basically, we are given a array numbers, and it contains integers, and it is sorted in non-decreasing order, or we can say increasing order. We have to return the indexes one indexed. It means we have to return the indexes, treating the indexes starting from 1 of 2 numbers, index 1 and index 2, such that they add up to give target number target, and index 1 should be less than index 2. And we have to note that both the indexes cannot be equal, therefore you may not use the same element twice, and there will exactly be one valid solution, and your solution should be O of 1 additional space. So we are not allowed to use any additional space. Alright, let me explain you the problem in short. Basically, in the problem we are given an input integer array, right? This array will be sorted in increasing order, and it will have numbers, and there is a target. We have to find 2 different indexes in this particular array, such that the element at those indexes, when you add those elements, it should be equal to target. For example, the given input is 1 2 3 4, right? 1 2 3 4. The indexes are 0 1 2 3, but the question says that we have to return the indexes treating them as a one indexed problem or a one indexed array. So the indexes will start from 1, so it will be 1 2 3 4. These are the numbers and these are the indexes, right? Now we have to find 2 different numbers which are equal to, I mean, when you add them, this should be equal to the target. The target is 3. So our numbers are 1 and 2. 1 plus 2 is 3, and their indexes are 1 and 2, right? So we return 1 comma 2. Now the thing is guys, we have already solved a problem. I think the problem was in arrays and hashing, and the problem was two sum. This two sum problem is very much same as this one. We have to find two numbers whose sum will be equal to the target. But in that solution in two sum, we have used an extra space. If I show you the solution now, you will see that we are using some extra space, a data, to store one number, and then we are trying to loop to find the second number. But now the question says that solve it without using any extra space. Solve it using O of one additional space, that is constant space. Now you will have to understand that the problem says that the data is sorted. The data which you will receive as an input will already be sorted. Now the simple thing is, if you have the input as 1, 2 and 3 and 4, right? My target is equal to 3, and this is under the two pointers technique. See, the thing is, why this can be considered as a two pointer problem, because we have to find two indexes, right? We have to find two such indexes that can add up numbers. That is, the numbers at those indexes should be added up and should be equal to target. Let us say there is an index left which is equal to 1, the starting index, and there is an index right which is equal to 4, that is the ending index. Why I am using this technique? The reason is, let me put my starting index here left, right? And then let me just add some space here for clarity. And then let me put another index which will be equal to right. So let me put right here. See, the thing is, if you add the numbers at the left and right index, it is equal to 5, right? 1 plus 4 is 5. Now this 5 is more than our target, right? How can you utilize this information? The data is sorted, and the question says that you will exactly have one valid solution. You will definitely have a valid solution, right? I am pointing my left index at the first one, the right index at the last one. The sum is, as of now, sum is equal to 5. Here you will have to understand that if the sum is 5, I have to get a target which is less than my sum, right? So anyhow, right now I am using the numbers as 1 and 4. Anyhow, I have to reduce the sum. If you want to reduce the sum, you will just shift your right index in the left side. Now this right will not be pointing to the number 4. This right should be pointing to the number 3. How is this going to help us? See, the thing is, if I am going in the left side, if I am using a number by going in the left side, then definitely I am reducing my sum. My sum will now be having two elements, 1 and 3, right? So it will be 1 comma 3, and sum will become 4. You will have to notice here that I have to reach to a target. Initially I got a sum as 5. Now I have to reduce it. If I move my left index in the right side instead of moving my right index in the left side, then the numbers will be 2 and 4, right? This is going to increase the sum, and this is because the data is sorted. Obviously this 1 will be less than 2, right? So if we are moving our left pointer in the right side, it is going to give me a number which is more than what we already have. But if we move our right pointer in the left side, it is going to give me a number which is less than what we have, right? We have 1 comma 4. Now we have 1 comma 3 if we move our right pointer in the left side. If the sum is 5, initially the sum is 5, my target is, let us say, 6. If my target is 6, I have to increase the number, right? My right index is already pointing to the highest number. My left index is pointing to the lowest number. I will move my left pointer in the right side to get a bigger number, because my current sum is 5, I need 6. But right now I need a target of 3, so I have to decrease the sum. For that I will move to a number which is less than what I already have. I already have 1 and 4. I want to move my right pointer because it is pointing to the highest number. Let me point to the second highest number. This is going to be our logic. Right now left is 1, right is 3. So we can say 1 comma 3, which is 4. I need 3. So again I will move my right pointer. I will say my right pointer will now move to the left element, which is 2 now. So now my elements are 1 comma 2. My sum is 3. I need a sum of 3. The target is 3. I got it. What are the indexes? The indexes are 1 and 2. Simply return it. So I don't think it is a medium level of problem. You just have to fetch what are the information you have, try to break the problem, and you will solve it very easily. So let's do it. We can say we have a left index which is equal to 0, right index which is equal to length of the numbers minus 1. I know we have to return the indexes as 1 based index. We are going to do it. For now let's do it in a normal way. I can say while left is less than right, we have to take the sum of our current numbers. My left is at index number 0, my right is at index number I would say the last index. So I can say if numbers of left plus numbers of right, if this is equal to the target, it means we have got our answer. We can say return left plus 1 and right plus 1, because we have to return as one index, right? Now if this particular data, numbers of left plus numbers of right, is more than target, that can be a case. So we can say elif, let me copy it from here, if numbers of left plus numbers of right is more than target, in this case I simply have to move my right pointer in the left side. So I can say right is equal to right minus 1, else there can be a case that this is less than the target, so it will be else. So I can say else left plus equal to 1. I think that should do it. If you run this should solve all the test cases. I think the sample test case is fine with this solution. Let me submit this and let us see is this able to pass all the test case. Yes, so we can see the solution is accepted and we have passed all the test case, and we are not using any extra space, guys, right? And we are solving it in O of n time complexity. We are just running a simple loop. So we have solved the second problem as well. Now let us go on to the third problem. The third problem says that the problem name is threesome, and in this problem we are given an integer array nums. Again we are given an array nums. We need to return all the triplets. Basically we need to return 3 different indexes or 3 different numbers, all the different triplets, where nums of I plus nums of j plus nums of k is equal to 0. Let us try to understand it. See, the thing is I, j, k are all distinct indexes. The output should not contain any duplicate triplet, and you may return the output and the triplet in any order. Now the question may seem a bit complex, but it is easy. Let me copy the input here. Let me try to explain you. Basically what you need is, we need 3 different numbers from this list such that when you add those numbers it is equal to 0. For example, from here what I can say is minus 1, 0 and 1. Basically these 3 numbers, when you add them it will be equal to 0, right? Also we have minus 1, then this particular minus 1 and 2. I can say minus 1 and 2. If you add them it will be equal to 0. I can also say minus 1, actually not this minus 1 but this particular minus 1, then this particular 1 and this particular 0. I can say minus 1, 1 and 0. This will also be equal to 0, right? If you add these 3 numbers it will be equal to 0. But now you will have to notice here, the first data and the second data are same, although the numbers are different. In the first data I am using 1, 0 and a minus 1, basically these 3 numbers. In the second data I am using 1, 0, the same 1 and 0, and this particular minus 1, this minus 1, right? But the question says that the output should not contain any duplicate triplet, and you may return the output and the triplets in any order. So this one is not going to be valid. We don't have to return duplicate triplets. Now one of the process to solve it can be just run 3 different loops, and anytime the sum of your numbers in these 3 loops is equal to 0, you can store that particular result. Let's actually try this. We can say first loop is going to be for I in the range of nums, not nums but length of nums, and then we should have for j in range, I can say from I plus 1 to length of nums, and for k in range j plus 1 to length of nums. Basically right now I am trying to find out all the different triplets I have in my array. For example, if I just print the data, I can say print nums of I comma nums of j comma nums of k. If I just run this, you will see that we are trying to find all the different triplets in our data. Okay, what's the error here? Your output was okay, it is expecting a return type. Let's give it a return. Let's return empty data for now. Alright, let's run this, and now you will see that we are basically creating all the different triplets. Minus 1, 0, 1. We will have minus 1, 0, 1. Then we have minus 1, 0 and 2. So we have minus 1, 0 and 2. Then we have minus 1, 0 and minus 1. So we have minus 1, 0, minus 1, right? Now what I can do is I can say s is equal to the sum of these 3 numbers, right? This plus this plus this, right? And if s is equal to 0, we should add these 3 numbers into our result. So let's actually create a result variable which is equal to a list, and I can say result dot append a list, because we have to return a data 2D array, and in this every list is having 3 numbers, those 3 triplets or the triplets whose sum is 0. So I can say nums of I comma nums of j comma nums of k, right? If I return the result, it is going to have the duplicate results as well, because we are not filtering out the duplicate data, right? So if I just run this as of now, you will see that the output is not valid. Your output is this one. We are returning this data. It is expecting this particular data. Basically these triplets are fine, minus 1, 2, but these 2 triplets are basically the same, right? We have minus 1, 0, 1. We have 0, 1 and minus 1. Both are same, basically containing the same elements. So now what we have to do is we have to eliminate all the duplicate records, right? Now to eliminate all the duplicate records, let's do one thing. Let's actually, when we are storing the elements, let's store them in sorted way. If I just say sorted, this will be sorted now. The data should be sorted. If I run this now, the data which you will see will be looking very much similar. It is minus 1, 0, 1, then -1 0 1, right? So now I can just pass this data in a set and it should eliminate all the duplicate records, right? But set wants a data which is hashable, so we should convert each of the list inside our data as a tuple. So what I can do is I can say result is equal to, let's convert it to a tuple. Let's convert each data inside our result as a tuple. So we can say tuple x for x in result. Basically we are trying to convert each of our triplet into a tuple, and now I can say let's pass this result in a set and convert it back to a list. So this will remove all the duplicate records. Let me run this. Let's see if it is able to pass the sample test cases. Yes, the sample test cases are fine. If I submit this, let's see if it is able to pass all the test cases. Yes, it is accepted, guys. We are trying to find all the triplets, right? Here we are finding all the triplets, and then we are checking if the sum of the triplet is 0, add them in the result. There is a result list, but when we are adding them, add it as sorted, because if you don't sort it, let us say if you don't sort this and run this, then basically the results might be different. These two data, they contain the same numbers 0 1 -1 and 0 1 -1, but they will not be looking same. They are not actually same, right? Their elements are in different order. So that is why we are sorting them, and then we are converting each of our data into a tuple so that we can pass them in a set and filter out all the duplicate records and then convert it back to a list. But this is not the optimal solution. This is O of n cube. This is O of n multiplied by n multiplied by n. This is the time complexity. But we can actually optimize the solution. If you see here, it says that the recommended time complexity is O of n square and O of 1 space. So we should not be using any extra space apart from our result. We are going to create a result, so that is going to be fine. But our time complexity, it should be O of n square and not O of n cube. Now let us see how we can solve it. And also guys, notice that we are actually trying to do it under the 2 pointers technique, right? So how 2 pointers can be applied here? See, the thing is, right now we are trying to find out 3 different numbers whose sum is equal to 0. Now if I sort my data, this is going to help me solve it in a very easy way. Let me tell you why. Let me get rid of this particular solution and let us say nums.sort. If I just print the value of nums now, you will see that the data is sorted. And I will tell you how can you think about this sorting. First of all, let me sort it. So this is my sorted data. So right now, whatever was my input, I converted my input in a sorted form. This is my input now. This is the same set of input, but the input is sorted. Now I want 3 numbers whose sum can be equal to 0. So I can say, let me consider -4 as my first number. Alright, this is my first number. So now I need 2 more numbers, right? 2 more numbers I need, and the sum of these 2 numbers should be +4, right? Because I am considering -4 as one of my number, and now I want that other 2 numbers which I select, this should have a sum of 4. So now my problem is, from the remaining set of data, try to find out 2 numbers whose sum is equal to 4. And we have already solved this problem. Just now we have solved this. If you remember the 2 sum part 2 input array is sorted problem, in this we are given a sorted data and we need to find 2 different indexes whose sum will be equal to target, right? And this is very much similar to 2 sum problem. 2 sum problem was in the arrays and hashing, right? In the 2 sum problem, we solved the similar thing. We are given a numbers array, we have to find 2 different numbers whose sum will be equal to target. Now the problem says that try to solve it with O of 1 space complexity. If we want to solve it in O of 1 space complexity, our data should be sorted. And then we can apply the same technique which we applied in the question 2 integer sum part 2. The data is sorted. Put your 2 pointers at the start, at the end. Try to find out the current sum. If it is more, then move your right pointer. If it is less, then move your left pointer. If it is equal, then you got your target. So that is why we initially sorted our data. After sorting, our problem is reduced now. We are considering the first number to be one number in our triplet, and let us see what are the different numbers we can create. And let us see what are the different 2 numbers we can get from the data, such that their sum will be, if it is -4, then the sum will be +4. If it is -1, then the sum we are looking is +1, right? And this is also going to solve our duplicate issues. We are not going to create any duplicate records. I will show you how. So let me keep this input here and let us try to start solving the problem. Let's create a variable result is equal to array. This is not an extra space we are using. This is the space we are using just to return our answer. So this is not for logic. This is just to store the answer. Now let us run a simple loop for I in the range of length of nums. Now our current number is equal to nums of I, right? So our target for the other 2 numbers will be current multiplied by -1, right? Because if it is -4, then we need +4 so that their sum is equal to 0. Now we are going to apply our logic which we did here in the problem 2 integer sum part 2. We are going to say left is equal to I plus 1, right is equal to length of nums minus 1. See, the thing is, right is going to point to the last number which is the highest number, and left is going to point to this particular data. When our current number is equal to minus 4, then this is our search space where we are trying to find out our other two numbers, and that is why my left is now I plus 1, which is index number 1 at this particular point. It should not be 0, otherwise it will start from here. It should be just after your current number, right? Now I can say while left is less than right, and now let us create a variable total which is equal to nums of left plus nums of right. And then if this total is equal to target, anytime the total is equal to target, it means we have got a triplet. So we can say result dot append, and then we can append nums of I comma nums of left comma nums of right. These are the three numbers we have, right? But if this total is more than target, in this case I can say that right minus equal to 1, else left plus equal to 1, right? If the total is less than the target, we need a bigger number, so we can say left plus equal to 1. And now I can say, after we are out of our main loop, we can say return result. Now this is not the complete code. As of now it is not complete. We are going to complete this. As of now, if I just break from here, that whenever we are getting the target, let's break, and if I just run this now, you will get some answer, right? As of now you are getting that the expected output is what you need, but this is still not the best answer. This is still not the perfect solution. Let me actually get rid of this particular data, or let me comment it. If I submit this should be giving us a wrong answer. So you can see we are getting a wrong answer, and the reason of this is our output is 0 0 0 0 0 0, right? Expected is 0 0 0. So we are not eliminating the duplicates, but I told you that this logic is going to eliminate the duplicate. To eliminate the duplicate, what we can basically do is, at the start of the loop for I in range of length of nums, we can say that if I is more than 0, that is if I is 1 2 3 4 at these indexes, and nums of I is equal to nums of I minus 1. If this is true, then we can say continue, do not do the processing. And the reason is, if the input is 0 0 0 0, then we are saying that this first 0 is our first number. Now let me try to find out two more numbers whose sum will be equal to 0, right? So it will be 0 0, these two numbers, right? But later on, when our I index will point to this number, which is this particular 0 at index number 1, then this 0 is at index number 1. Now we are trying to find out two more numbers whose sum will be 0. So we are going to get these two numbers again, right? So what we can basically do is, we can say that if any time the two continuous numbers are same, let's ignore it for the numbers which are same. Let's not do the processing. We are going to say if this is a 0, it is fine, it is the first 0 we have received. But if this is a 0 and the previous number is also 0, let's continue. Let's not do the processing. Let's not assume the first number to be the same. And this way you can eliminate the duplicate records. If I just submit this, you will not find the duplicate records. Still the answer is wrong, which is fine. We are going to solve it. And I will tell you why we are getting the wrong answer. The reason is, now we are able to eliminate the duplicate records. Let me actually write that input. If we have an input 0 0 0 0 and I run this, you will see that we are able to pass this test case. The test case number 3 is fine, but now the test case number 1, the sample test case, is not fine. We want this minus 1, 0 and 1, but we are not getting it. And the reason for this is our data, right? When we are at this particular number minus 1, then we are getting two different answers. The answers are minus 1, this minus 1 is our first number. Then we are having this particular minus 1 as our second number, and this particular 2 as the third number. Now the sum is equal to 0. Basically, when your first number is minus 1, this particular data, then you are saying that I want two numbers whose sum will be equal to plus 1. These are the two numbers. But I still have more numbers which can give me plus 1 as a sum. These are the two numbers which can give me plus 1 as a sum. Basically, this minus 1 can be my first number, this particular number, and 0 and 1 can also be some data, right? But what we are doing is, as of now, is whenever we are finding a result, keeping the first number as same in our first loop, we are breaking, right? Here we should not break. We should try to find out the other answer we can get starting from minus 1. So for this, what we can do is, we can say we should not break the moment we are getting an answer. Rather, we should try to find out more answers which are starting from this particular number, and there are two other numbers which can give me the total sum which I need, which can give me the target sum I need. So the moment I get an answer, I can simply say while left is less than right and nums of left is equal to nums of left plus 1, we are going to say left plus equal to 1, And again for right also we have to do, we can say while left is less than right and nums of right is equal to nums of right minus 1. So we can say right minus equal to 1. What we are basically trying to do here is, let me tell you, first of all, when this is our input, we are first sorting it. So it will be minus 4, then it will be minus 1, then minus 1, then 0, then 1, then 2, right? With minus 4 as the first number, we are not going to get any result. But when minus 1 is our first number, the target we need is plus 1, right? Now our inner loop, while left is less than right, will process this particular data, minus 1, 0, 1, 2, to find out two different numbers whose sum will be plus 1. We can say this is our first number, minus 1 is our first number, and then 2 is our second number, right? Minus 1 and 2. This is our left, this is our right. Okay, so we got a sum of plus 1. It is fine as of now. As of now, here is our left, here is our right, alright? So now we will move our right pointer in the left hand side in order to get some other result. So we can say this is our right pointer. Let's move this right pointer in the left hand side. So first of all, let me reduce the right index here. I can say right minus equal to 1. Now we are having this logic to eliminate all those duplicate records. I will tell you how. What it is doing is, it is saying that till the current left and the next left are same, move your left pointer in the right side. Till your right pointer and right minus 1 pointer are same, move your right pointer in the left side. Now how is this going to help us? See, the thing is, the moment we get an answer with this minus 1 and 2, we are going to say this is our right, this is our left. We are again going to start our processing with keeping the first number as same. So left is minus 1, right is plus 1, their sum is equal to 0. We need a target of 1, right? So we need a bigger target, so we are going to move our left to 0. So now our left is at 0, right is at 1. Left plus right is equal to 1. We got our target. So now we are going to get minus 1 as the first number, 0 and 1 as our second and third number. But this particular while logic is to eliminate any duplicate records. Let me tell you, if it is 0, 0, 0, 0, right? This is our first number. 0 is our first number. If 0 is the first number, then the target will itself be 0 for the other three numbers. Now this is our left, this is our right. With left plus right, we are getting an answer which is equal to 0. So 0, 0 are the other two numbers. Now if I simply move my right pointer in the left side, it is still equal to the same number. So we cannot keep this right pointer here because our first number is fixed, our third number will be fixed, so our second number will be same as well, right? So this is going to create duplicate records, and so that is why we are eliminating that duplicate records. First of all, we are saying that if my first number is the same, don't process it. If my second number is the same, don't process it. If the third number is the same, do not process it again. So we are moving our pointers, and before moving our pointers for the second and third number, we are actually saying that right minus equal to 1. The moment I get an answer with nums of right, right will be minus equal to 1. And I think this should not be left plus 1, this should be left minus 1, and this should be right plus 1. Because we have already moved our right pointer in the left side. So if our right pointer is at index number 4, we are going to move it at index number 3. So now we are going to compare index number 3 and index number 4 to check that are we trying to process the same number. And similarly for the left also, if our current left and the previous left is same, then we are going to move our left pointer again, right? So let me submit this. This should pass all the test cases. So yes, you can see it is passing all the test cases. And this is the complete solution for this particular problem. I know this is a bit complex to understand. What I will suggest you guys is try to visualize the problem with a pen and paper. Then you will completely understand it. And this logic is O of n square because we have a single loop here. And then inside this we have another loop. So it is O of n square and we are not using any extra space for our logic. We are just using a space for our answer, right? So I think this should be good. Now let us move to the next problem, and the next problem is container with most water. In this problem, you are given an integer array heights where every data in the heights array represents the height of the ith bar. You may choose any two bar to form a container and return the maximum amount of water a container can store. Alright, so we are given a container which looks something like this, and this container has different bars. You can see bar 1, 2, 3, 4, 5, 6, 7, 8, right? They have a heights. Height is 1. Then 7, then we have 2, then we have 5, then we have 4, then 7, then 3, then 6. Now you need to store water in this, right? But you have to store maximum amount of water that this particular bar can store or the container can store. In this particular data, you can see that if you choose to store water between the bar number 2 and the last bar, if you choose to store some water here, then we are able to store 36 liters of water. How is this happening? Because the height is right now around 6. And the width is around 6 as well. I think 1, then 2, then 3, then 4, then 5, then 6. So when you are trying to find out how much area of water you are storing, it will be height and width. So there are two factors. The height matters and the width matters, right? Now you might think that why cannot I just store the water between the two highest bars? This way the height of my water will be around 7, right? But the width will be just 1, 2, 3, 4. So the amount of total water will be 7 multiplied by 4, which is 28. But if you just choose to store till 6 within this bar and this bar, because you cannot store water up to this point, right? It will overflow, right? So you can store water till this particular point. So the height of your water is restricted to 6, but the width is now 6 as well. So 6 multiplied by 6 is 36. So we have to find this maximum area we can cover, right? For that, what we can do is we can actually use a two-pointer technique, and it is going to be very simple. Let me tell you how. Let us create a left variable which is equal to 0. The right variable will be length of heights minus 1. What we are basically trying to do here is, let me actually copy the input. I will tell you why are we applying two pointers here. See, the thing is, what we are trying to do is we are trying to create the maximum width and the maximum height. No, we are trying to find out the maximum area, width multiplied by height. The maximum width will be when you are storing the water between the first and the last, right? So that will be your maximum width. What about the height? The height will be the minimum of your current data. For example, if I choose the height 1 and height 6 bar, then you will be able to store water till this point, right? Up to this point. But you will be able to store water with a more width. Width will be from this point up to this particular point. So the total width will be 1, 2, 3, 4, 5, 6, 7, right? But the height will not be 6, right? Because the height will be minimum of the two bars between which you want to store the water. This bar can allow to store water till the point number 6 or the height 6. But if we are choosing this bar, it will allow us to store water till height 1. So at max we can store till height 1, but the width will be 1, 2, 3, 4, 5, 6, 7. So now what we can do is we can simply say that we need to find the width multiplied by height, that is the area as the maximum. So let's create a result variable which is going to be 0 as of now. Then we can say while left is less than right. Now we can say the width will be equal to right minus left, because right is at index number 7, left is at index number 0. Their difference is going to be the width, right? It is not the number of elements, it is the width. The width will be the difference between the last index and the first index. The last index is 7, the first index is 0. So their width will be 1, 2, 3, 4, 5, 6, 7. The last index 7 minus first index 0. So this is the width. What will be the height? The height will be the minimum of the two bars where we are pointing as of now. So it will be heights of left comma heights of right, and the area will be equal to width multiplied by height. Our final result will be the maximum of the current value of result and the area, right? And now we can say return area, or not area but result. It is going to show the maximum. But we also have to move our pointers, right? Now this is of height 1, this is of height 6. Since this particular height is more, we want to keep this height, because if we move our pointer from right to right minus 1 or left to left minus 1, our width is definitely going to decrease. So we cannot avoid decreasing our width, but we can avoid decreasing our height. What we can do is we can say, out of the two poles at which we are right now, let's get rid of the pole which is having less height. So this pole has a less height, right? So we can say if the heights of left is less than the heights of right, in this case let me move the left pointer, else we are going to move our right pointer. So we can say right minus equal to 1. If this height is more and this is the less height, we are going to go from left to left plus 1. This is our left pointer now. Again we are going to calculate the area and assign our result. And now between these two poles, we got the output or the result as 36. Now we are going to move this pole to this particular pole to find out how much water we can store between this particular pole and this particular pole. This way we are going to find out the different area of water we can store, and we are only going to store the maximum value as the result. This should do it. This particular solution looks good for this. Let's submit this and see if we are able to pass all the test cases. So yes, we are able to pass all the test cases with this particular solution. So this is the logic behind it, and you will see and observe that almost in every two-pointer technique we are using this logic. There is a left pointer, there is a right pointer. We are moving our left pointer and right pointer based on the condition. Your whole focus should be to finding out what should be that condition based on which we are going to move our pointers. If you are able to find it, you will be able to solve it. Now let us move to the next problem, which is the hardest problem as of now, which is trapping the rainwater. In this, you are given an array of non-negative integer heights which represents an elevation map, and each height of I represents the height of a bar. Alright, what we have is the height of bars, and it has a width. Every bar has a width of 1. We need to return the maximum area of water that can be trapped between the bars. Alright, so what we have is we have a heights. We have different bars and we have heights. So the height of the first bar is 0, then it is 2, then it is 0, then it is 3, then we have 1, then 0, then we 1, then 3, then 2, then 1. We can actually store water between the bar with height 3 and bar with height 3, and between this we can store 1, 2, 3, 4, 5, 6, 7 blocks of water, and between the height 2 and between the height 3 we can actually store 1 and 2 more blocks of water, so a total of 9. That's the maximum area of water that can be trapped between the bars. See, the thing is we cannot store water here because we do not have a bar in the left side. The water will flow and it will not be trapped, right? We cannot store water in these 2 blocks because from the left side it is going to be overflowing and it will not be trapped. The recommended time and space complexity for this problem is O of n time and O of n space. Alright, let me tell you how we can solve this. And again, it is a 2-pointer technique, and I will tell you why. The thing is, we need 2 different points between which we can store our water. So definitely it is giving us a signal that we can use 2 different pointers to point out and try to find out how much area of water we can store. First of all, let me create a result variable which is 0, and let me create a variable n which is equal to length of heights, or the height. Now first of all, let me write out the inputs. So the input is this one. Now let us try to process each input one by one and try to see what's the answer we are getting. Alright, as of now it is 0, right? So at this point we can store 0 amount of water because we do not have anything in the left side which can contain water, right? Now we got a bar with height 2. So we got a bar with height 2. So let me actually create bars as well. Alright, now we get to see 0, right? The moment we get to see 0, at this point I do not know about the other bars. Will you be able to store water? No, because if you store water in this and in this particular block, it will flow in the right side. If you store water in this and this particular block, it will flow in the left side. But now I see a 3, right? The moment I see a 3, I can say that I got a block of height 3, right? So let me actually create this. Now the moment I see the data 3, I can say that we will be able to store water in this particular block and in this particular block. But how can you find this? How will the 3 identify that we can store 2 blocks of water? See, the thing is, this 3 should know that what's the highest height we have in its left. In its left, it has a height of 2 and this has a height of 3. So it can store a block of 2. I will tell you why. Let us say this has a height of 3 and let us say this has a height of 3, or not 3 but 4. Let us say this has a height of 4. Alright, if this is 4 and the moment you see a 3, how much water can you store? You can actually store 1, 2 and 3 blocks of water, right? How are you able to identify this? From this 3, in the left hand side, what's the highest bar you can see? It is 4, right? The moment you see a 4, you can identify that we can store some block of water here. Since my height is 3, the left bar height is 4, I can store the maximum amount of water will be the minimum of 3 and 4. Why the minimum? Because you cannot store a block of water at this particular point. It will flow from the right side. But if it is 2, then in this case you will not be able to store water in this particular block. It will flow in the left side, right? So whatever is the minimum, that much you will be able to store. So at each point I want to know what's the maximum in its left, right? Now if I see a height of 1, I see a bar and the height is, let us say, 1. Alright, now from 1, how can you find the answer? How much water can you store? You will not be able to store water when you see 1, but right now we discussed that what's the value in the left side? The maximum value is 3, and now I can say my current height is 1, the maximum height is 3, so we can store the minimum water which is 1, right? But we cannot store it. Where are you going to store this? You do not have a space to store it. How are we going to identify this particular problem? So we are going to deal with this problem, don't worry about it. As of now, let's move on to the next data which is 0. So when it is 0, we do not have any bar. So again the same problem. You will see in the left side, the highest value is 3, right? But between 3 and 0, the minimum is 0. So you will be able to store a water of 0. So just looking in the left hand side is not giving me the complete information. So let me actually draw the whole bar and then I will tell you how we can solve it. Now we were looking in the left side. What about looking in the right side? Let us see what information are we getting when we see in the right side. Alright, so we are going to see in the left side and we are going to see in the right side. Now let's try to process the data. We have a 0 here. Look in the left side, you don't have anything. Look in the right side, what's the highest bar size you have? The highest bar size is 3, right? Is this giving me any extra information? Can I store water here? No, I cannot store water here because my current height is 0. The highest left is, let us say, 0, and the highest right value is 3, which is this one. This is also 3 and this is also 3. So the highest is 3. Now when I see this 2, the highest value in the left side is 0. The highest value in the right side is 3. But the minimum of 0 and 3 is still 0, right? So let me create a result and this will be 0 and this will be 0. Basically, let's choose the minimum out of it. Now when we are at this particular point, the highest bar height in the left is 2. Basically this particular bar. So the left highest is 2 and the right highest is 3, right? At this moment, we will be able to store some water, right? Here we are storing 2 liter of water. How can we identify it? Okay, are we taking the minimum out of it? Yes, we are taking the minimum, which is 2. We have one more logic, but explaining that logic here will be difficult. Let's move on to the next bar. It is 3. What's the highest you can store in the left side? It is 2. What's the highest in the right side? It is 3. Then what is the minimum? The minimum is 2, right? At this particular bar, you will not be able to store any amount of water. But we are getting the answer as 2, right? Now how can we modify our logic is, simple thing is, when we are at this particular bar, we are looking completely left. We are looking just in the left or just in the right. We are ignoring the current bar. The current bar and its height is also important. So what we can basically do is, when we are finding the left max or the right max, let us include the current bar height as well. So when we are at 0, the left max will be 0. When we are at 2, the left max will be 2, including the 2 as well. When we are at 0, the left max will be equal to 2, because this is the left maximum. When we are at 3, the left maximum will be equal to 3. So this is the left max. Now when we talk about the right one, it will be for 0, the right max is 3, basically this one. For 2 also, for this 0 also, and for this particular 3 also, the right max will be 3, right? So this is fine. But now the result is 2. Here the result will be 2. We are just taking the minimum, and the minimum of this will be 3. See, the thing is, we are able to store water at this particular location, basically these 2 liter of water. The reason is, here we have a height of 0, so we can trap the water here, right? For this particular bar where the height is 0, we have a left max of 2, right max of 3, so we are taking the minimum, because between those points I can trap water. But we can only trap the water if its current height is less than the maximum in the left and less than the maximum in the right. Then only we will be able to trap the water, right? Its height is, let us say its height is 2, then you will not be able to trap any water here, right? Its current height is 0, and that is why you are able to trap some water here. When I talk about this particular bar, the leftmost maximum here is 3 itself, the rightmost maximum is 3, and the minimum is 3. That is, we will be at max able to store 3 liter of water. But we should have space here, right? Then only we will be able to store water. So what we can basically do is, we can say, from the result, we are going to say minus the current height as well. So if we just minus the current height, you will notice that we are actually getting the answer. 0 minus 0 will be 0, 2 minus 2 is 0, 2 minus 0 is 2, and 3 minus 3 is 0. That's the answer we should have. 0, 2, 0, 2. That's the amount of water we can store. And you will see the magic at this particular point. Here the bar height is 1. So the left maximum at this particular point is 3, because we have a 3 here. The right maximum for this particular bar is also 3. So the maximum amount of water we can store at this particular bar will be the left max and right max minimum out of the left max and right max, which is 3 itself. But the current bar height is 1. It is telling me that although I can store a water of 3, but since its height is 1, 3 minus 1 is 2. I can only store 2 liter of water because its current height is 1, right? So this point will store 2 liter of water. And how are we sure? Because I am sure that in the right side there is a bar of height at least 3, which is going to stop and trap the water. There is a bar in the height in the left side which is going to trap the water, and my current height is just 1, so I can trap 2 liter of water. That is going to be our logic to solve the problem. And guys, this is hard, so you might have some difficulty understanding it, but I think if you just focus on visualizing the problem, solving it on a pen and paper, you will be able to solve it. Now let us try to solve it. So we can say left max is equal to a list and right max is equal to a list. Basically for each point we will find the left and right max. So left max is a list of n elements and right max is a list of n elements. As of now they are 0. So for the left max, for the first element, the element itself will be the left max because it doesn't have any element in the left side. For right max, for the rightmost element, the element itself is going to be the right max because it doesn't have element in the right side. So we can say left max of 0 is equal to height of 0, and we can say right max of n minus 1 is equal to height of n minus 1. That's our initial data. Now let's run a loop for I in the range of 1 to n. Let's try to fill the left max array. So we can say left max of I is equal to maximum of current value of height of I, and we can say left max of I minus 1, whatever is my previous max and my current height. The maximum out of it will be my left max at index number I. Similarly for right, we are going to run a opposite loop. So we can say for I in range of n minus 2, not n minus 1, because we already calculated for n minus 1. So n minus 2 till minus 1 comma minus 1. We are running a opposite loop, right? So I can say right max of I will be equal to max of current value of height and right max of I plus 1, right? The next data we have, basically for this particular data, 1 itself is the right max. For this particular data, either 2 will be the maximum, or in the right side we have maximum as 1. So out of 2 and 1, whatever is the max will be the right max for 2. So that is the logic here. Now we can just run a simple loop for I in the range of n. Now let us try to build our answer. We can say result is equal to result plus minimum value of left max at I comma right max at I. That is going to be our maximum capacity at this point, but we are also going to say minus height of I, because height of I is a bar. On the bar we cannot store water, we can store water above the bar, so we have to say minus height of I. I think that should do it. If I just return the value of result, you will see it is a very clean solution. We are just finding the left max for each point, right max for each point, and then we are applying our logic. And if I just submit this, I think this should pass all the test cases, but we have to actually return the result. We don't have to say result, we have to say return result and submit this, and this should pass all the test cases. Yes, it is accepted. So we have solved all the 5 problems of, I would say, the 2 pointers for NeetCode 150. And I hope that you are able to understand the solution of all these 5 problems. What I want from you guys is try to understand each problem one by one. Go from easy, then medium, then hard. Try to visualize the problem and you will have the complete understanding of it. In the next video of this series, we are going to solve all the problems of the sliding window technique. The sliding window technique does involve a lot of 2 pointers technique as well. Make sure that you practice all these 5 questions of the 2 pointers technique and then only move to the sliding window. So guys, I think that's it for this video. If you got to know something from this video, then make sure that you hit that like button. And if you are not subscribed to my channel, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.